Section 7.2 talks about hypothesis testing for a mean when we know the population standard deviation, when we know sigma. And so it says, once again, the decision to reject or fail the null hypothesis depends on the p-value of the test statistic. So it says, decision based on the p-value. We're to use a p-value to make a decision in a hypothesis test. We're going to compare the p-value with the value for alpha. Okay, alpha kind of looks like this. It's the Greek letter A. So it says, number one, if p is smaller than or equal to alpha, then we're going to reject the null hypothesis. And if p is greater than alpha, then we're going to fail to reject the null hypothesis. Okay. So here's the first problem. It says the p-value for a hypothesis test is p equals 0.0237. What is your decision if the level of significance is A, and it says alpha is 0.05? Okay, so notice what we're trying to do here. We're going to do a comparison between p and alpha. So for part A, I'm going to write p, which is 0.0237, and then I'm going to write alpha over here, which is 0.05. And I want to know, is this number smaller or equal to, or is it bigger than this one? So if you sometimes people have a hard time figuring that out, and I say just look, do a little comparison here. So the 0, they're the same. The 2 is smaller than the 5, so I know this is going to be less than or equal to, right? Okay, so we know it's less than or equal to, and if it's less than or equal to, then we're going to say we are going to reject the null hypothesis, okay? All right, now we're going to do the same thing for part B. I'm going to rewrite down my number P, which is 0.0237, and I'm going to write down my alpha, which in this case, alpha is 0.01, and I'm going to start comparing. So 0 and 0 are the same. 2 is bigger than 1, so this is going to be greater than. And since p in this case is greater than alpha, then this is, we're going to say we're going to fail to reject the null hypothesis, okay? So now let's take a look at the next piece here, and it says, how do we find the p-value for a hypothesis test? It says, after determining the hypothesis test standard test statistic and the test statistics corresponding area, do one of the following to find the p-value. If it's a left tail test, then p is going to be the area in the left tail. If it's a right tail test, p will be the area in the right tail. And if it's a two-tail test, p will be the area in the tail of the standard test statistic. Okay? All right. So number 2 says, find the p-value. Find the p-value for a left-tailed hypothesis test with a test statistic of z is equal to negative 2.23. Decide whether to reject the null hypothesis if the level of significance A is 0.01. Okay, so first thing I'm going to do here, I'm going to look for my z-value of negative 2.23. So remember, this here is 0. Negative 2.23 would be somewhere right about here. Okay, and we're looking for the area to the left, right? So remember, if I'm trying to find the area to the left, the way I'm going to do this to find my p-value is I'm going to go normal CDF, CDF, and I'm going to go negative 9999 and a negative 2.23. Okay, so let me get my calculator. It's right here. Move it over. Let me turn it on. Let me clear that out. Okay, so we're going to go second vars. And we're going to go down to normal CDF. And I'm going to hit negative 9999, comma, a negative 2.23. Okay. And hit enter. Oh, come on. There we go. Oh, what did I do wrong? Number 1, go to, I hit a parenthesis somewhere in here. Okay, let's just do it again. So, sorry about that, guys. Second vars. normal CDF, and we said negative 9999, comma, negative 2.23. Close it off, hit enter. Okay. And so we got our p-value. With my p-values, guys, because it is the probability, like if I was using my table, remember my area under the curve, I always had 4 decimal places, so I'm going to go ahead and go 4 decimal places here. So I'm coming up with p is 0.0129. P is 0.0129. Okay? And so now what we're going to do is we're going to decide, are we going to reject, or we're going to fail to reject? So I need to compare p and alpha. So right here, I'm going to write my number for p. Right here, I'm going to write my number for alpha. So for p, I'm coming up with 0.0129. And for alpha, we just have 0.01. And so if I compare these two, p is bigger than alpha. Okay? So then we say, okay, well, what happens if it's p is bigger than alpha? So I'm going to come back over here, and look what it says. It says if p is bigger than alpha, then we're going to fail to reject the null hypothesis, right? So right here, I'm just going to say we're going to fail to reject the null hypothesis HO. Okay? That's all I'm trying to do there for that particular problem. All right, number 3 says, find the p-value for a left tail hypothesis test with a test statistic of z is negative 1.71. Okay, so the first thing I'm going to do here, I'm going to find look where my z value is. So remember, this is 0. Negative 1.71 would be somewhere right about here. Negative 1.71. And again, I'm looking for the area to the left, right? Okay. So if I'm looking for the area to the left, the way I'm going to find my p-value, same way we did the one before, we're going to go normal CDF, again, negative 9999, and then negative 1.71. Okay. So let's find our p-value. So let me get my calculator again. I go second vars, normal CDF, negative 999, oops, forgot the negative, there we go, 9999, comma, negative 1.71, okay. And I am coming up with p, again, to 4 decimal places, 0.0436, so 0.0436, okay. So now, the next thing I need to do, I need to compare my two numbers, p and alpha. So p in this case is 0.0436. Alpha in this case was 0.05. So I know that p is smaller than or equal to alpha. Okay. So when p is smaller than or equal to alpha, what I'm going to do, I'm going to come back over here. Let's see, if it's smaller than, then we're going to reject the null hypothesis, okay? So right here, I'm going to type in, I'm going to write in reject the null hypothesis, okay? All right. So number 4 says, find the p-value for a two-tailed hypothesis test with a z statistic of 2.14. Decide whether to reject the null if the level of significance alpha is 0.05. Okay, so first thing here, 2.14. Okay, so if this is 0, 2.14 is going to be right about there. And this is a two-tailed test, y'all. So there's going to be another one right here. Okay, and these are the areas that we're looking for. So you might say, okay, how do I find this area? So 2 ways you can do it. You can say, let me look for this area to the left, or let me look for that area to the right. Okay, which one do you decide to do? That's really entirely up to you. Okay, and then I'm going to show you how we're going to get our p-value. So if I suppose wanted to find the area to the left, remember, I'm going to do the same thing we've been doing. I'm going to go second vars, I'm going to go normal CDF, negative 9999, comma, negative 2.14, close it off, and I'm coming up, I'm going to go to 4 decimal places again, 0.0162, Okay, so the area here is 0.0162. That means that the area here is 0.0162 because these graphs are symmetric, right? So the way we find the p-value is we're going to take twice, we got to add those two numbers up together. So 0.0162. That's going to give me my p-value, okay? So 0.0162 times 2 is 0.0324. Okay, 0.0324. This is my p-value. Why? Because we have a two-tailed test. So again, I'm going to do the same thing we've done before. I'm going to compare my p with my alpha. 0.0324. Alpha was 0.05. Okay. Now we know that p in this case is smaller than or equal to alpha. So you say, okay, what do we do? So guys, I don't have to keep going back up and forth to look at that little thing. I kind of made a little cheat sheet here for y'all, and I'm going to give it to you. So if you notice right here, let me see, I think I can draw on this dummy end. Yes, we can. So let's take a look at this business right here. And if p is smaller than or equal to alpha, what are we going to do? We're going to reject the null hypothesis. So here we're going to say we are going to reject the null hypothesis. Okay. All right. So the next part we have here is using p-values for a z-test. So a z-test for the mean mu says it's a statistical test for a population mean. The test statistic is the sample mean x bar. And here's how we do our finding our standardized test statistic z. Okay. Sample is random, the population is normally distributed, or n has to be bigger than or equal to 30. Okay, so using p-values for a z-test with mean mu. Number one, we want to make sure that we know the population standard deviation. Okay. Number two, we're going to state the claim mathematically and verbally. We're going to identify the null and the alternate hypothesis. We're going to specify the level of significance, which is identifying our alpha. We're going to find our standardized test statistic using this formula aquí, right here. And then we're going to find the p-value. And if we have, if it's a left tail test, p is going to be the area in the left tail. If it's a right tail test, p will be the area in the right tail. And if it's a two-tail test, p will be twice the area in the tail of the standardized test statistic. We're going to make decisions to either reject or fail to reject the null hypothesis. And we're going to interpret the decision in the context of the original claim. So, boom, 8 steps, right? That's a whole lot. Yes, it is, but I'm going to try to break it down. Hopefully, as I like to say, easy, breezy, cover girl, right? That's my objective here, guys. Okay, so here's my first problem. Problem number 5 says in auto racing, a pit crew claims that its mean pit stop time is less than 13 seconds. Okay, I'm going to stop right there. Remember the symbol we use for the mean? We use mu. And it's saying is less than. So this is less than 13 seconds. This here, y'all, is my claim, right? Because they are claiming it. So now that I know that mu is less than 13, I need to do the opposite of that. What's the opposite of saying something is less than? Saying that it is greater than or equal to. Okay. Now that we have that, the second thing we're going to do, we're going to identify which one of these is the null hypothesis and which one is the alternate hypothesis. So just a friendly reminder, the null hypothesis is always the one that has the equal to part. If there's an equal to, whether it's greater than or equal to, less than or equal to, or just simply equal to, that's going to be my null hypothesis. It's going to be my HO. Okay, and then so then this one here is going to be my HA. Okay, so now we are going to say because my HA is pointing to the left, then this is going to be a left tail test. Okay, so I want you to look at my alpha here. My alpha here, alpha is 0.0324. 0.01. Okay. All right. Second thing we're going to do, we're going to find our standardized test statistic. We're going to find our critical value. Okay. So let's see. The way we're going to do this, we're going to write x minus mu over my standard deviation divided by the square root of n. Okay. So now let's see. I'm going to keep reading in my problem. It says a random selection of 32 pit stop times. Okay, so I'm going to stop right there. What does that mean? It means that my n is 32. Has a sample mean of 12.9 seconds. That's my x is equal to 12.9. Okay. Assume the population standard deviation is 0.19 of a second. Okay. So my standard deviation is 0.19. Okay. So let's see. Yes, x bar right here. Sorry, x bar right here. Okay, so now let's see if we can go ahead and do a little plug and chug type business. So let's see if we can do this. Let's see. X bar is 12.9 minus mu, which we said was 13, divided by, let's see, our standard deviation was 0.19. Let me clean this up so it looks a little bit better. 0.19. So 0.19 divided by the square root of n, which was 32. Okay. So now what I'm going to do, I'm going to take my calculator and I'm going to enter all this in there. So let me clear out my screen so it looks a little bit better. Okay, we're going to go 12.9. Oops. Come on, pen. 12.9 minus 13. Okay. Divided by 0.19 divided by the square root of, what was it, 32? Okay. So again, my calculator opens up parentheses for me when I do my square root, so I got to close out those parentheses, and then I got to close off the ones that I did when I opened up right here in front of my 0.19. And now I'm going to hit enter. And the z-value I'm coming up with is a negative 2.98. Oops. Yeah, negative 2.98. Okay. Now we got our z-value. Okay. So now that we have our z-value, what we're going to do is we're going to figure out how do I find the p-value for that. Okay. So I'm looking for, if this is 2.98, what's the p going to be equal to? So remember how we're going to find the p if this is a left tail test? We're going to go normal, CDF, and again, we're going to the left because this is a left tail test. Oops. Negative 9999 and negative 2.98. So let me get my calculator again. Let me clear this out. Second bars. Normal CDF, negative 9999, comma, negative 2.98. Okay. And the p-value that we're coming up with is, I'm going to go to 4 decimal places, 0.0014. Okay. So p is equal to 0.0014. Now remember what we're going to do. We're going to compare our p number to our alpha number. So the p number is 0.0014. Alpha happened to be 0.01, and we know that 0.0014 is smaller than or equal to. So when I come back over here, look what happens when it's smaller than or equal to. Then we're going to reject the null hypothesis, right? So now we're going to say we're going to reject the null hypothesis. Okay, so now what's the next step? Because we're not done yet, okay? I know you're tired, I'm tired too. We reject the null hypothesis. So now the next step is I'm going to come back to my cheat sheet, okay? So now we have to look at this piece here. Okay, so let me do this, like that, and like this. Kind of make this little box. Okay. What was our claim here? Was our claim the null, or was I claim the alternate? Let's go back and double check. Our claim happened to be the alternate, and we are rejecting the null hypothesis. So when I come back here, because my claim was the alternate, because my claim was the alternate, and we're rejecting the null hypothesis, then we're going to say there is enough evidence to support the claim. So now I'm going to say there is enough evidence to support, come on, pen, the claim. Boom. And we're done. Okay? So there's a couple of steps that are involved. Okay? A couple of steps are involved. The first thing, guys, again, I know this is new for probably all of us here, but the first thing is we're always going to write the claim. Once we find the claim, then we're going to state the opposite of the claim, and then we can determine which is our null and which is our alternate. Once we do that, then we're going to look for our test statistic Z, standardized test statistic. Then we're going to find the area, notice right here, that corresponds to Z, and then we'll compare the P and the alpha. And then we can either interpret the decision to either, is there enough evidence to support the claim or not enough evidence to support, and we'll be able to figure all those things out, okay? So look, we're going to do another one. Again, it's just going to take a little bit of time to get used to it, but I hope that after we do a couple, it'll be a little bit easier, okay? That's my hope. Excuse me. So look, let's take a look at number 6 here. It says, a study says the mean time to recoup the cost of bariatric surgery is 3 years. I'm going to stop right there. Just reading that first sentence, the mean time, remember this is my mu, to recoup the cost of bariatric surgery is 3 years. This is equal to 3, okay? This here, y'all, is my claim, okay? So what's the opposite of saying something is equal to 3? By saying something is not equal to 3, okay? So now that we know that, then we got to figure out which is my null and which is my alternate. The null always has the equal to part, okay? So the part that's equal to is this one here. This is my hoe. And where my hoe's at? I'm just kidding, guys. My alternate, or my null. And here is my A, my ha. Okay? So now we have that part there. We know that our null is, that mu is equal to 3. We know the alternate is that it's not equal to 3. The second thing we got to figure out, left tail, right tail, two-tail test. We always look at this business right here, okay? Once we find that, then we know that, then we know that that is going to be a two-tail test, okay? So we're going to have this piece here, and we're going to have this piece here, okay? Now, let's find our standardized test statistic. My z-value is going to be equal to x bar minus mu divided by the standard deviation over square root of n. Okay, so let's keep reading here. We randomly select 25 bariatric patients. What does that tell me? Tell me that n is 25. And we find that the mean time to recoup their cost for surgeries is 3.3 years. So my x bar is 3.3 years. And it says, assume the population standard deviation is 0.5 of a year. So my population standard deviation is 0.5. And the population is normally distributed. Is there enough evidence to doubt the study's claim that alpha is 0.01? Use a p-value. Okay, so first thing we're going to do, we're going to continue with finding our standardized test statistic. So x bar is going to be 3.3 minus our mu, which is 3, divided by my standard deviation, 0.5, divided by the square root of 25, okay? So I'm going to grab my calculator once again, and I'm going to turn it on. There we go, clear this out. So I'm going to go 3.3 minus 3 divided by 0.5 divided by the square root of 25. Okay, and hit enter. And okay, let's make sure. Did we get the right thing? Let me just double check, guys. Sometimes when I come up with a real pretty answer, I'm always a little skeptical. Doesn't mean it's wrong. Just want to double check. 3.3 minus 3, okay, divided by the square root of 0.5 divided by the square root of 25. We close it again. And okay, so got it again. I'm okay. I'm feeling better about it. Came up with z equals 3. All right, so let's see what this means now. Okay, so now what we're going to do here, we came up with our critical values, right? And so, sorry about that. Okay, so this is 3 here. I'm sorry, negative 3. This is positive 3. I'm looking for the area under those pieces there, okay? So the way I'm going to find my area, remember, I'm going to take my calculator, I'm going to clear this out. I'm going to go second vars. I'm going to go to normal CDF, okay? And I'm going to go negative 9999, comma, negative 3. And so the area that I'm coming up with here is 0.0013. 0.0013. So then that means that the area over here is 0.0013. Okay. So now remember, I need to find my p-value. Guys, because this is a two-tailed test. The p-value is going to be when we take this area and add them together, or we can multiply it by 2, and that's 0.0026. Okay. So here's my p-value. Now, I need to compare my p-value and my alpha. So my p-value was 0.0026. Our alpha in this case is 0.01. Okay. So this value here is smaller than or equal to, right? Okay. So now, what does that mean? Let's come back to my little cheat sheet. What happens when p is smaller than alpha? If p is smaller than alpha, again, we are going to reject the null hypothesis, right? So, oops, sorry about that. Okay, so we're going to say, we are going to reject the null hypothesis, okay? Now that we've rejected the null hypothesis, the second thing we need to figure out, which one is our claim? So if you look here, our claim was the null. So when I come back to my cheat sheet, okay, my claim was the null, and we are rejecting the null hypothesis. So now we're going to say there is enough evidence to reject the claim. So all I'm going to do right here is I'm going to say there is enough evidence to reject the claim. Okay. All right. So guys, I also put this problem in here. You have a problem exactly like this in your homework. And I want you to look at the directions here. So the directions are telling me match each p-value with the graph that displays its area without performing any calculations. And it says explain your reasoning. P, the first one, P is 0.2061, and the other one is 0.0146. So remember what P stands for. P stands for the area underneath the curve. So if you were to think about these in terms of percentages, this would be 20.61%, and this would be 1.46%. So obviously, which is the bigger one? Well, this is the bigger one, right? So now, wouldn't this one here be the 20.61, and this one here would be the 1.46? So now it says the graph for which one? The graph for B displays the area, and the graph of A displays the area because the p-value is the same as the area. Okay. All right. So I'm going to show you one extra thing here before we. Okay, so the next thing I'm going to show you is there is a way to do this on your calculator or the calculator app. Okay, and these right here are basically the screens that we're going to use to do this. So I'm going to show you how this is going to work. I'm going to scroll back up to the first problem that we did here. Okay, and I want to point out, guys, I would use this sort of feature to double check your answer because I don't think it does much more than just help you double check your answer. Okay, so I'm going to get my calculator going here. Let me clear it out. Okay, and the first thing I'm going to do, I'm going to go to Stat, and I'm going to scroll over till I hit Tests. And because we are using the z-scores, I'm going to use a z-test, which is number 1. Okay, enter. And I'm going to go with stats here. Okay, so I'm going to make sure I'm on the stats feature. And the first thing is saying, what's my mean? Okay, and our mean in this case was 13, so I put 13 right here. Okay, and then what was our standard deviation? Our standard deviation was 0.19, so I put 0.19 here. And what was my x bar? My x bar in this case was 12.9. Okay, and our n was 32. Okay, and then the next part is we're going with our claim, and our claim, it's saying that it is what, less than 13. So if you notice right here, I'm clicking this one here for less than. I can kind of move it around, but I want to do the less than one, and I'm going to go. Once I do that, I'm going to hit calculate, and I want you to notice something. What did it do for me? It gave me my z value. Well, there it was right there, negative 2.98. And it gave me the p-value. So the p-value I had here was 0.0014, and that's the same value I had right there. And then all I'm doing is I'm comparing my p-value to my alpha. Okay? So it's doing a little bit of that double checking for me. Okay? So look, I'm going to do the same thing here in the next one. I'm going to go through this problem. I'm going to use my calculator to double check my answer. Okay? So let's clear all this business out. I'm going to hit Stat. I'm going to go to Tests. And I'm going to do a Z-test. Okay? And we're still going to go with our stats here. Okay, so what is our mu in this case? Our mu is the number 3. Okay? Our standard deviation was a 0.5. Okay? Our x bar was 3.3. Okay? My n in this case was at 25. Okay? And our claim, my HA here, my HA was a two-tailed test because it's not equal to. So I'm going to select that one. I'm going to hit enter so that because remember my HA tells me whether it's a left tail, right tail, two-tailed test, right? So it's a two-tailed test. Then I'm going to go to calculate. And let's see, did we come up with the same numbers here? I got my Z, look, I got my 0.26. There it is right there. And again, I'm comparing my 0.26 with my alpha for me, okay? So that feature is going to help you a little bit. It really helps you more in terms of checking your answers, okay? So let's see. Here's the next part here, and it says a similar way to decide whether or to reject the null hypothesis is to determine whether the standardized test score, the z-score in this case, falls in the rejection region of the sampling distribution. It says a rejection region or a critical region of a sampling distribution is the range of values for which the null hypothesis is not probable. If a standardized test statistic falls in this region, the null hypothesis is rejected. The critical value z0 separates the rejection region from the non-rejection region. Okay, so there's a couple of steps here, and it says finding the critical values in a normal distribution. Number one, we're going to specify the level of significance alpha. We're going to decide whether the test is left tail, right tail, or two tail. We're going to find the critical values for Z0. And it says if the hypothesis test is left tail, we're going to find the Z-score that corresponds to an area of alpha. If it's right-tailed, we're going to find the Z-score that corresponds to an area of 1 minus alpha. And if it's two-tailed, we're going to find a Z-score that corresponds to half of alpha and 1 minus half of alpha. Then we're going to sketch the normal distribution. We're going to draw a vertical line at each of the critical values and shade the rejection regions. Okay, So for the first problem here, it says find the critical value z0 in the rejection region for a left tail test with alpha being 0.01. Okay, so we know that alpha is 0.01. We're trying to find the z-value, okay? So if we're trying to find the z-value, meaning we're looking for what is the value of z when the area underneath my curve is 0.01. The way we do this, guys, is we're going to go inverse norm 0.01. Okay, so I'm going to take my calculator. Here we go. Let me clear this out. Okay, so I'm going to go second vars, and I'm going to go down to inverse norm, and I'm going to type in 0.01. Oops. 0.01. And hit enter, and the z-value that I'm coming up with is negative 2.33. Okay, so my z-value is negative 2.33. Okay, so let's see. Let me get my eraser going. Come on, pen. Here we go. So negative 2.33 right here. Okay. All right. So this part here is what we call our rejection region. And this part here is what we call our fail to reject region. Okay. And I'm kind of just using this business right here. Okay. So now number 8 says find a rejection region with for a two-tailed test when alpha is 0.05. Okay, so let's do the same thing here. Okay, so since we're doing a two-tailed test here, excuse me, I want you to notice here that it says the way we're going to find our z-score is we're going to take half of alpha and 1/2 of alpha, okay? So let's think about what I really mean by that. If alpha is 0.05, then half of alpha, think about it this way. What's half of a nickel? 2.5 cents, right? And right here. So remember, the way I'm going to find my z-value is I'm going to go inverse norm, and I know that the area underneath that right there is 0.025. So let me take my calculator. We're going to go second vars. We're going to scroll down to inverse norm. We're going to hit 0.025, close it off, hit enter. And to 2 decimal places, I'm coming up with negative 1.96. So this value here is negative 1.96. This value here is positive 1.96, right? These are my rejection regions. So reject and reject. I know I'm writing over it. And then I'm just going to abbreviate here. This is going to be fail to reject. Okay? And it's basically this picture right here that I was kind of going with. Okay. All right. So now let's see, take a look at, we got a couple of problems here. See if we can't figure these things out. It says employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors. So I'm going to stop right there. Okay. The mean salary. So remember what we call the mean salary. Mu is less than one of its competitors, which is 68,000. So the claim is mu is less than 68,000. Remember, this is my claim. Okay. So if this is my claim, what's the opposite of saying something is less than? Saying something is greater than or equal to 68,000. Okay. Now we got to identify which one of these two is my null and which one is my alternate. My null always has the equal to part. So here's my ho, and here's my ha. Okay. Now the next thing, guys, is remember the ha tells me whether the test is left tail, right tail, or two tail test. Because this is pointing to the left, this is a left tail test, okay? This is a left tail test. So we know here that the alpha is 0.05. What I want to do, I want to figure out what is that z value right there, okay? So the way I'm going to do that part is I'm going to go inverse norm of 0.05. So let me get my calculator here. We're going to go second vars, inverse norm of 0.05. Okay, hit enter. And I'm coming up with negative 1.64. Okay. So the value we're coming up with here, negative 1.64. All right. So again, just to give you a reminder, this is the reject. This is the fail to reject. Okay. So now it says a random sample of 20. So I'm going to stop right there. Remember, N is 20. Of the company's mechanical engineers has a mean salary of $66,900. My X bar is 66,900. Assume the population standard deviation is 5,500. And the population is normally distributed. And it says at alpha is 0.05 tests the company's claim. Okay, we're going to do just what we've been doing before. We're going to find our z-score. Okay, so remember, I'm going to take X bar minus mu, oops, there's no bar in the mu, divided by the standard deviation over the square root of n. Okay, so I'm going to take 66,900 minus 68,000, okay, divided by 5,500 over the square root of 20. Okay. Now, guys, I'm going to do all of this business here on my calculator. So let me clear this, move this over, clear it out. Okay, parentheses, 66,900 minus 68,000, okay, close that off, divided by 5,500, divided by the square root of 20, okay. Close my parentheses off and hit enter. And the z-value that I'm coming up with here, remember this is going to be my z-value, I'm coming up with a negative 0.89. Okay. All I'm trying to figure out now is that negative 0.89. Where would that number fall? Okay. Where would that number fall, excuse me, on this number line? Okay. So I know right here in the middle is 0, right? And if here is my negative 1.64, wouldn't the negative 0.89, negative 0.89, oops, 89, it looks so messy, let's fix that up. Negative 0.89, wouldn't that fall right about there? And that falls into which region? My fail to reject region, right? Okay, so we are failing to reject, right? We're failing to reject. So now, what does that mean? I don't know. Let me go back and look at my cheat sheet. I know I'm failing to reject. So I know I'm going to be in, sorry. I know I'm doing this, right? So I'm going to come back and say, okay, which one was my claim? Oh, well, notice my claim was the alternate. Okay, so since my claim was the alternate and I'm failing to reject, then all I'm going to say is there is not enough evidence to support the claim. Okay, so right here I'm going to say, oops, there is not enough evidence to support the claim. Okay, and that's number 9. Okay. Let's see, let's do number 10, and I think we're done with this section after this one here. Okay, first off, start reading the problem. A researcher claims that the mean cost of raising a child from birth to age 2 by husband-wife families in the United States is $13,960. Okay, so what are we going to say? Mu is 13,960. Okay, this here, y'all, is our claim. So what is the opposite of saying that something is equal to? By saying something is not equal to 13,960, right? So remember, now that I have that part, which is my null always has the equal to part. So that's my ho, and the other one is going to be my ha, okay? So now, second thing we're going to do, we're going to look at our ha. Because this is not equal to, this is telling me that this is going to be a two-tailed test, okay? So we're going to have our two tails like that. And if alpha is 0.10, then each of these here would be 0.05, okay? Because it has to be half of them. And I need to find those, those critical values here, okay? What's the value here and what's the value here? So the way I'm going to do that, I'm going to go inverse norm. Oops. Inverse. That looks so messy. Inverse norm of 0.05. So let me clear this out. We're going to go second vars. We're going to go inverse norm of 0.05. Close it off. Hit equals. And I'm coming up with a negative 1.64. Okay, so the two critical values we have are negative 1.64, positive 1.64. Okay, so again, just to give you a heads up, these are my rejection regions, and this is my fail to reject region. Okay, so now I'm going to keep reading the problem. So continue to read the problem. It says a random sample of 500 children. So what does that tell me? N is 500, has a mean cost. So my X bar is 13,725. Assume the population standard deviation is 2345. So my population, my sigma, is 2345. Okay. So what are we going to do now? We're going to find our test statistic, okay, our Z value. Excuse me. So remember, it's going to be X bar minus mu over sigma divided by the square root of n. So I'm going to start, start writing this out. 13,725 minus 13,960 over sigma, which was 2345, divided by the square root of 500. Okay, and we're going to figure out what we end up with. Okay, so clear this out again. Parentheses 13,725 minus 13,960 divided by 2345 divided by the square root of 500. Close and close again, and then hit enter, and I'm coming up with negative 2.24. Okay, so now when I come back over here and I say, okay, where would I find negative, oops, a little too much, oh, I didn't want that. All right, where would I find negative 2.24? Negative 2.24 would be somewhere over here, and that would fall in the rejection region. Okay, so what am I going to say now? I'm going to say we are going to reject the null hypothesis, right? So I know I'm rejecting my null hypothesis. Second thing I want to do, and I need to figure out which one of those was my claim. Look, the null was my claim. So if I'm rejecting the null hypothesis and the null happened to be my claim, I'm going to come back to my cheat sheet. So we are rejecting the null hypothesis, and the null hypothesis for my claim, we're going to say there is enough evidence to reject the claim. Okay, so right here I'm going to say there is enough evidence to reject the claim. And let me see. Oops. Yes, that is all of 7.2, guys. Okay. Y'all got questions? Let me know.